Hi everyone. The next section, the 4H, the increasing and decreasing annuities and perpetuities. So we think about the fixed interest rate, but the amount of the payment is increasing over time or decreasing over time as a linear function. So this is one important section for the exam because this kind of annuity is common because if we consider the inflation, the amount of payment has to increase over time. And also the formulas are relatively more complicated than the usual annuity immediate and annuity due. So those are the reasons that this section is important and often appear in the exam. Okay, so at first we want to define the increasing annuity and that we state the theorem to calculate the accumulated value of this interest. Okay, so what is increasing annuity? Increasing annuity is the annuity with increasing payment as a linear function. So $1 at time 1, $2 at time 2, $3 at time 3, up to $n at time n. We generalize it in the later videos, but for now that we think about this cash flow, and this cash flow is called increasing annuity, and that we define the accumulated value as IS right angle n. And if we define this IS right angle n as accumulated value, then IS right angle n is equal to S double dot right angle n minus n over I. That is also equal to 1 plus I times S right angle n minus n over I. Because double dot basically accumulates 1 year of interest. So that is 1 plus I times S right angle n. We can also define the present value and also annuity due version. So similarly that we define, okay, so we have n years, 1, 2, 3, n years, and $1, $2, $3, up to n dollar. And the present value is defined as IA right angle n. And also accumulate the double dot version. So if payment start at 0, $1, $2, $3, $4, up to n dollars at time n minus 1 and time n, the no payments. Then this present value is called the IA double dot right angle n, or accumulated value at time n. So this is equal to, we defined this as IS double dot right angle n. So we can define these quantities in the same way. And you can see that these have just the time point difference. So if we think about the time 0, time 1, time n minus 1, and time n, basically these four quantities are the value at different time point, but its value is essentially the same. So, okay, so basically the IA is here, and the IA double dot is here, and the IS is here, and the IS double dot is here. So just the difference is the 1 plus I to the power something. So 0 to 1, we have to multiply 1 plus I, and from here to here, that we have to multiply 1 plus I to the power n minus 1. Then again, that we multiply 1 plus I. So basically, this gives all formulas. So at first, what is the present value of annuity immediate, increasing annuity immediate, IA right angle n? So this is going back n years. from the accumulated value. So 1 plus I to the nth power times is right angle n. So this is equal to a double dot n. So s double dot becomes a double dot, and n becomes n times v to the nth power over I. Or we can write this as 1 plus I times a right angle n minus n vn over I. So the calculator BA2 plus is convenient to calculate a right angle n, but not necessarily a double dot right angle n. So it's good to express all formula without double dots. So you can see this has slightly more complicated shape than IS, the right angle n, because we have this, the v to the power n. So originally it has just the negative n, but this becomes the negative n times v to the nth power. Okay, second formula, what is a double dot right angle n. So this is just, this accumulates 1 year of interest compared to this. Okay, so you can multiply 1 plus I. So this is 1 plus I times IA right angle n. So yeah, so basically we have to multiply 1 plus I, but 1 plus I over 1 plus I is equal to D. So if we use the quantity D, it's expressed in a simpler way, simplest way. So A double dot N minus NVN over D. So this is the formula. And how about IS double angle IS double dot right angle N? So this is, okay, so we have to multiply 1 plus I to the nth power. So 1 plus I to the nth power IA double dot right angle N. So this becomes basically S double dot. Okay, so this becomes S double dot right angle N minus N over D. Okay, so A double dot becomes a S double dot since we accumulate n years of interest. And the Vn, V to the nth power disappears when we multiply 1 plus I to the nth power. Okay, so now that we proved the theorem. So the expression for IS right angle N is simplest, but also the proof is most straightforward. Okay, so the proof. So the increasing annuities, that we decompose this cash flow into n different annuities. So time point 0, 1, 2, 3, n minus 1 up to n. So we want to calculate this accumulated value IS right angle n, but we decompose the original $1. $1 is here, and the $2 as 1 plus 1, and $3 as 1 plus 1 plus 1, and so on. Then finally we have n minus 1, and maybe I would write the 3 ones. Then finally 1. Okay. So yeah, so maybe I would say that we have n payments here, and we have n minus 1 payments here. Okay. So now that we think about this horizontally, what's the present value of these payments? So this is simply the n time, so the $1 payments for n times. So accumulated value AV at t is equal to n is equal to S right angle n. Okay. So this is equal to S right angle n. And the second one, what's the accumulated value? So you can see that we just have n minus 1 payments. and the accumulated value. So this is simply S right angle n minus 1. So the technique is kind of similar to block payments, maybe a special case of block payments. And the third one, we have, okay, so n minus 2 payments, n payments minus this and this. So this accumulated value is S right angle n minus 2. We evaluate the at the last payment. So this is S right angle n minus 2. And finally, we have S right angle 2 and S right angle 1. So the summation of this is accumulated value. So this means that the IS right angle n is equal to S right angle 1 plus S right angle 2 plus up to S right angle n. Okay, so we write down the formula for S right angle n, in general, S right angle t. So this is equal to t is equal to 1 to n S right angle t, and that is the I on the denominator and the 1 plus I to the t's power minus 1. So now we think about this term. So summation of the 1 plus t to the t's power, 1 plus I to the t's power. And actually this can be simplified further. So note that this summation t is equal to 1 to n, the 1 plus I to the t's power. This is geometric sequence. And actually this is equal to the S double dot n. Why? Because if we think about the time diagram, zero, 1, 2, 3, n minus 1, n minus 2, n. Sorry, n minus 2, n minus 1, n. Then actually, 1 plus I at time n is worth $1 at time n minus 1. So I would write that this is $1 and this is equal to 1 plus I. Okay, so $1, $1 at t is equal to n minus 1 is worth 1 plus I dollar at t is equal to n. And in the same way, $1 at time n minus 2 is worth 1 plus I square dollar at time n. So we continue this, then $1 at the time one, that is n minus 1 years before time n. So this is worth 1 plus I to the power n minus 1. And finally, this $1 this $1 is worth 1 plus I to the nth power at time n. Okay, so in this way, we can equate the value. So we want to calculate t is equal to 1 to n summation 1 plus I, sorry, the summation t is equal to 1 to n, 1 plus I to the t's power. But okay, so t is equal to 1. Okay, so this is, okay, so this is equal to 1 plus I plus 1 plus I square up to 1 plus I to the nth power. But actually this amount is the accumulated value of these payments. Because the $1 at time n minus 1 is worth 1 plus I, $1 at time n minus 2 is worth 1 plus I square, and so on. Yeah, and this accumulated value of this, the orange payments, is worth S double dot right angle n by the definition of S right angle n. Yeah, so that's why this is equal to summation t is equal to 1 to n 1 plus I to the t's power is equal to S double dot right angle n. Okay, so now that we want to calculate this quantity, and this quantity is equal to S double dot right angle n minus n, right? So maybe I would say that this is equal to summation t is equal to 1 to n 1 plus I to the t's power minus n over I after taking summation. Then the first term is S double dot n. So S double dot right angle n minus n over I. So this is the IS right angle n. So this is the end of the proof.